Okay, transformations. We have two transformations here in part A and part B. First one is we have to recognise that as a stretch, horizontal or in the x direction, scale factor 2. Now remember, it's 2 because when you've got an inside change, inside the brackets, it affects x values, and it does the sort of opposite of what you'd expect. So with this being half, it makes it a scale factor 2. And in a minute, that's going to be a translation, k units to the left, not to the right. So, stretch horizontal scale factor 2. Here's what a lot of people did and got it wrong. They looked at the curve, completely ignored the axes behind it, and just stretched the curve about its line of symmetry. So this is the wrong answer. A lot of people were really confident they got that right, but actually it's wrong. You did actually get a mark for that, because it's the correct curve, but it's in the wrong place. So there's the line of symmetry. That's what a lot of candidates did wrong by assuming that the line of symmetry there is the centre of this stretch. But actually the centre of stretch is there, is the axis. So let's start again. And this time, instead of thinking about what the final curve is going to look like at the beginning, we're just simply going to double all of the x values of the curve. Well, at least for a few key points. Because that's really what a stretch horizontal scale factor 2 means. It just means all of the x values for points on the curve are going to double. So starting at the bottom, coordinates of this are 1 minus 4, so that's going to go to 2 minus 4. And then just pick up on wherever the curve passes through coordinate grid points. There's one. 2 minus 3 is going to become 4 minus 3. And then this one on the axis it's currently at 3, 0, it's going to go to 6, 0. And then there's one more up there, which is at 4, 5, so it's going to go to 8, 5. And then carry on going, but back the other way. We did the bottom, didn't we? That went to there. Now what about this one here? That has coordinates 0, minus 3. When you double 0, you still have 0. So actually that's going to be invariant. It's going to stay where it is at that point. That one there, minus 1, 0 is going to go to minus 2, 0. And then probably the one at the top, last one, minus 2, 5 goes to minus 4, 5. And you can see very clearly the curve is there. You do need to just draw it in. And there you have your final answer. Okay, part B, we've already established that this is a translation, k units to the left. So visually you should be able to see that the two curves are, there's no other transformations been applied. So you should just be able to look at the coordinates over here, which was 1 minus 4, and now it's at minus 2 minus 4. So it must have gone left 3 units. But just so it's clear, on here I've just drawn the original curve, and we can see that all of the key points on that curve have moved left 3 units. So k is just 3.